Hello everyone, it's time to start. Let me share screen. At the beginning of the today's class, I'll provide some important information about our course. The course is called Time Series Analysis. We will focus on forecasting and studying different forecasting models like ETS, ARIMA, and some models from machine learning, for example, random forest. You will have seminars and lectures. 6 seminars by me and lectures by Boris Demishев. Couple of words about grades. So you can get more than 10. Homeworks have weight 20%, 10% each. Datacam courses 5 and 5% group project, one final exam, and optional courses maximum 4. And the first optional course can give you 4%, the next one 3%, and so on. So these courses can be any which are connected to time series analysis. Here you can see deadlines. Okay. This, for example, this is deadline for first home assignment. This is a deadline for Datacam course number 2, and so on. In slightly different format, it looks like this. So the first deadline is Datacam course. Information about this course, how to find it, how to get access to Datacam, and so on, you can find in this document. I'll send it in the chat. And I'll share a join link. Please click it and join our Telegram chat. So you can ask any questions regarding our course in the Telegram chat. So do not hesitate to ask. We will work today. I'll use Jupyter Notebook, but alternatively you can use Google Colab. If you have not installed Anaconda, I highly recommend you to use Google Colab. Just a second, I'll send you a link to to this, yes, to this website. It is Google Colab. Or you can use Deep Notes or other programs or websites. Do you have any problems with access to Google Colab or with the installation of Jupyter of Anaconda? Okay. If no questions, let's continue. I want to start with basics of Python and what you can do in Jupyter Notebook. In such notebooks, you can write a code or a text. For example, if you want to make notes, for example, like here, you should choose Markdown cell. So here, Markdown, and execute it. To execute, press Shift and Enter. If you want to write a code, choose code. It is a default option here, and write some code. If you use Google Colab, here it's in Russian. It can be translated as code and text. So two types, either code or text. If you want to add comments in your code, add sharp and, for example, some code. 4 plus 5, it's 9. So you can use it as a calculator. But if you change a type to Markdown, you cannot get an answer because this is a text for Jupyter Notebook. Okay, got. Now some information about modules, functions, and so on. If you use something for the first time, you need to install this function. For example, let's install a module called SKTime. To install, write pip install SKTime. We need to install it once and then use it as an installed module. For example, if you've already installed it, you can work with it. For example, you can import some function from the module. Let's import. Let's work with module NumPy. It is a very popular module in Python. It contains a lot of functions, for example, for mathematical computations to find maximum, minimum, standard deviation, and so on. From NumPy, import function. What functions does it have? If you want to see a list of possible options, you can type dot and then push tab. What do we have here? Absolute. So, absolute. Sorry. Argmax. Well, a lot of functions. But if we want to work with one function, we can choose this function and import it. And it should be notice that a module can have modules inside it. For example, NumPy has another module, random, and this module has a function, for example, normal. Yes. This function is used to generate a normally distributed random variable. To use it, so we import it. Therefore, we can use it, and after every execution, we get different numbers because it is a random variable. It's a realization of a random variable. Inside it, we can add different arguments to see what arguments are possible. We can press shift up. Okay, we can specify location. The equivalent of location is mean of a random variable. Location, for example, 8. And what else? Scale, it's a standard deviation. For example, whatever. And size. If you want to get one number, you can set size equals 1. Okay. Or if you want to obtain more numbers, set the necessary size. For example, 10. To obtain 10 random numbers from this distribution. If you do not specify them, this function will use default values. For location it is 0, and for scale it is 1. And size is, oh, let's try 0. So size is 1. Equivalently, you can use different code to do the same. In our first example, we use this template from module import function and use this function. The second the second possible realization of this is import module. For example, we can import this module or just NumPy. Let's import this one. And here you can add a short name, for example, NPR. And use instead of NumPy random dot function, so we want to use this function instead of NumPy random. We can use NPR, but we can use it only if we add SNPR. Without SNPR, we cannot use it. And the last option, without without a short name, import module. Okay. And then first put the reference to a module and then dot function from this module. You can import just NumPy and do the same. Let's proceed. If you want to read a short documentation, some information about the function, you can use a question mark and then a name of the function. Or you can do it you can use Shift tab to see short description of a function. If you want to see other functions in this module, press tab. I've already said it, but I want to repeat because it is important and probably you will use it very often. What do we have here? For example, binomial distribution, beta distribution, Dirichlet, chi-squared, exponential, gamma, and so on. A lot of functions. Normal. First, you install a module and then you work with it. Import functions or import the whole module. For example, if you want to use a lot of functions from this module, probably it's better to import all functions, but it depends on the module because it can contain a lot of functions, and you download a lot of files, and if that doesn't work. Ilya, do you work in Jupyter Notebook or?
Yes, it is a Jupyter Notebook on Mac.
On Mac.
Mm-hmm. I just type tab and it doesn't show me.
I see. Actually, I don't know. I have Windows. Oh. Ilya, did you put dot after the function?
So I just type, for example, NumPy, I dot, and after that I click on tab, right?
Yes.
No, it doesn't work.
You can try to find it in the internet. Sorry, I don't know.
Okay, thank you.
Now let's start something interesting. First, install needed packages, modules, functions, and so on. We'll work in these functions from SKTime. First, install it. Then import SKTime datasets. There are datasets in SKTime, building datasets. Let's use one of them. Airline. We'll use the following dataset: load airline. Loading. Import. Load series. So the first one is our dataset, and the second function is function to plot time series. Let's assign our dataset to Y. Load airline. What we can do with it, we can see a structure of this object, and it is a time series. We can we can see a shape of this object. As you can see, it is a series. It means that it's like a vector. It's not a table, is a matrix n by m, and a series is a vector, something 144 by 1. Let's look at first 9 observations. What we can do? What else we can do? We can, if it is necessary, apply describe to see some descriptive statistics of our series. For example, the number of observations, mean, standard deviation, minimum, maximum, and it is a value 25% of observations below this this value. Well, let's plot it. We installed a special function for import plot series. Yes, nothing happens because we import these functions. To see plots, we need to use this function to apply it to our series, plot series, and inside our data, y. So, and do you still have a problem with visualization, this plot series function? Or now it works?
From after the entering the skTime.dataset, import load airline, and then from there, showing it once more. From there, yeah.
You have this part of the code, right?
Yes.
So you need to use plot function and inside it put your data. So it's not necessary to use y, you can just put this data set inside.
Okay, so after that step, plot underscore series load, or you have to start from y load airline?
Yes.
Y load airline, okay. I'll try.
Mm-hmm. Okay, does it work now?
Oh, sorry, I haven't typed it yet.
Now I have a question to you. What do you think? What type of data do we have? Is it daily, monthly, quarterly, semi-annual, or annual data? And how can we know it? Well, for example, we have 144 observations and 12 years. Yes, it's monthly data. Okay, 12 years, each has 12 months, and 12 multiplied by 12, that is exactly 144. Okay, let's proceed. And now we want to use simple and not so simple forecasting models. We will start with naive forecasters and then use one ETS model. But before it, let's split our data into test and train. Do you know why we need to split the data? If you want to apply different models, why do we need it? Exclude. What do you mean by exclude bias? Okay, we will use different models, but our goal is to choose the best one, the best forecaster. And if we will apply it to all data, we cannot evaluate how good it is. We need to split the data because we want to estimate the parameters of the model on some data on the first part and then apply our model to the second part. Why? Because we will have right answers for the second part. We have correct data, and we'll obtain forecasted forecasts from our models, and we can compare real values and forecasted values. But before test set, we cannot evaluate, choose the best model. Okay, let's split our data. From SKTime forecasting model selection, import temporal train test split. So first import function temporal train and train test split. This function produces two time series. The first one is so it splits our data into two parts. That's why we need to use two objects, two variables, yTrain and yTest, and We want to get a result of this function as a sorry. Okay, never mind. These two objects are just two parts of our time series. The first one is before some threshold, and the last one is after. To if you want, this function has two arguments. The first one is our series y, and the next one is the size of test sample. Since we have monthly data, so it is it's better to use something proportional to 12, but we can use like any number. Let's use 24. It can be just any number. It will use 2 years. Okay, and so we can check shapes of our new objects. Well, the shape of the first object is 120, and so you see this if we set here put here 3 years, we will have different sizes of our test and train samples. Now let's plot test and train. Use this function. We need series, and the next argument is labels. Train. First one is we need to check train, and next test. Okay. As you can see, so let's use 2 years. This function is good for visualization because we just need two strings to produce this this nice picture. Okay. We completed data preparation step. Let's proceed this our first forecaster, and I didn't say about it, but you can use markdown cells as you can use LaTeX code inside these cells. For example, now I want to write one step ahead forecast. How we will obtain one step ahead forecast. It will be equal to the previous value. I showed coronavirus cases for in the first class. So I didn't find anything which is visualized good and yeah, just perfectly visualized. For example, let's look at coronavirus cases in Russia. And for example, we want to predict the next. Yes. Code for this line. I'll choose Markdown and write it as in LaTeX. Okay, for example, you want to predict the next value of the coronavirus cases. How can we do it? We can just take the last observation. For example, it is this number. Just take it and say that it is our forecast. It is the simplest forecaster. Let's apply it to our time series. To use naive forecaster, we need to guess what, import a function from skTime forecasting naive import naive forecaster. Okay, sorry. Now create a new object called naive one forecaster. It will be our naive forecast, which we will use later. Naive one forecaster, and now dot and fit, and now it is an important. You can make a mistake here because you can use it for all the data, but it is a mistake because we want, as I've already said, we want to feed the data to estimate the model parameters, to build the model, and so on and so forth on the first part. Therefore, just here we need to use ytrain. Imagine you are not you don't know this part of the data. You know only this part. Okay. Now we should specify a horizon. Horizon is the number of observations. Yes, the number of observations we want to predict. For example, in our case, we want to predict 24 observations. We create an array which contains numbers from 1 to 24. We use 25 here because it works like this. The first number is included, but the second one is excluded. For example, if you want to have an array from 1 to 9, you should put here 10 instead of 9, because 10 is excluded. Okay, horizon, and let's make our first predictions. This function, the result of this function is our predictions. But to obtain it, sorry, the result of forecaster.predict. Predict, and inside it's write a horizon. Oh. Horizon. Yes. The interpretation of this like this code is the following. We want to use a forecaster. What forecaster? Naive forecaster, because naive one forecaster equals it is this function, and we want to obtain predictions. The following number of predictions for this horizon. Okay, and now let's plot our predictions. Y train, Y test, Y fit, and labels. Now we will have how many labels? We will have every time we have the same number of labels as the number of objects here, so 3. If forecaster 1. Okay. And I return. It's here. So our forecast is just the previous number. This hat, we do not forecast this hat. So it's a very simple model. And as we can see, okay. Just add import numpy s and p, and before it pip install numpy. Just add this code. And tell me, does it work now? Or this is NumPy, and to use it, we need doesn't work. Works. Okay. And okay. So this code, we use a range function from NumPy. I've installed it in this part. Okay, sorry. In the previous class, I import NumPy, another module. Now I understand why we have this problem. Okay, it should work. Luke, could you send a screenshot or explain your problem? Why the code doesn't work? So you can send a screenshot in the Telegram chat.
Okay, I'll do that.
Okay, let's proceed. And our next forecaster is a brother of the first naive forecaster. That is very similar. Let's look at our data. We have seasonality, and instead of just last observation as a forecast, we can use the value of a series 1 year before. Just to implement it, let's so we need to copy, but we already import a naive forecaster. We can remove this line, and inside naive forecaster we can add seasonality period. And in our case, it is 12. In case of semi-annual data, it is 2. For example, sorry. In case of weekly data, it is 7. Okay, we have monthly data, 12. What else do we need? Let's predict. We can do everything in one cell. We don't need more. We can separate it and use 4 or do everything in one. Now let's change the name of our forecaster and the name of predictions and the name of our forecaster. Yes. And seasonality period. Horizon is the same, and we don't need to put it here because we created this variable before, and now we can visualize it. Instead of ypred, we have a new variable, this new predictions, ypred2. So let's visualize it. And it looks much better, right? Yes, it is simple, naive. We just repeat the last pattern, but it is better than just constant. And do you want me to send? Okay. Do you want me to send this code now or after our class? Now, okay. What? Let's continue. The first model which we'll study, if I'm not mistaken, next Monday on the lecture, will be ETS model. It is a class of exponential smoothing models, and this abbreviation stands for error, trend, and seasonality. Let's see more details. I'll send this link to you. For example, we want to use the AAA model. Additive, error is additive, trend is additive, and seasonality is additive. To find the specification of this model, functional form, you should look at the first like the first letter. Later, in our case, it is A. Therefore, we need to choose the first one because A is additive, and to find AAA, we need to choose this model. And for example, if you want to work with MAN, M, the first letter, N is trend, because the second letter is trend, and ETS and seasonality is additive. So we need this model. Okay, let's use this model. You will discuss everything during the lectures, but now I just show you what kind of model we'll use and for forecasting. So to use it, we need repeat, change a little bit our code and repeat the same steps. Now we need, instead of naive forecaster, auto ETS, and let's rename it ETS. Our model is AAA. Here, instead of, we need to add parameters. We need to specify that our model is AAA. To do it, we need to add error, trend, and seasonal. And each one is add, but it doesn't mean that we add it. It means additive. If for model MAA, here we should, instead of add, use multiplicative. But let's use simple model ETS AAA. Let's apply it. It is our third predictor. And third predictions use forecaster. ETS forecaster. Horizon was specified before. Okay. And now instead of just change number, and here let's write ETS AA. Error and yes. Instead of naive forecaster, we need to use auto ETS. Now, so you can see the difference between true and predicted values is much smaller. We can choose the best model just looking at plots. We need to apply special functions and tests. But for the first seminar, it is enough. Okay. What else? We can visualize. We can plot a picture with all predictions. To do it, let's add first predictions, second predictions, and third. And here, don't forget to add labels. Naive 1 and naive 2. Yes. Now all predictions on the same plot. Tells. Yes, of course. Okay, now it's your turn to do something. You need to repeat everything, but cannot import. Cannot import ETS. Oh. Okay. Did you write this code? Did you use it? Okay, I see. Yes, because I have a mistake. Thanks. Should be, sorry. It should be not naive, but ETS. Yeah. Okay. You can use any data sets to repeat the same, repeat naive forecast 1 and 2 and simple ETS model. So you can use any data set, but I have two suggestions. The first one is financial data from Yahoo Finance. To work with this data, install this module Yahoo Finance, then import because Yahoo Finance is YF, and I'll send this code. I'll send this code in the Telegram chat. Here you can find tickers. For example, it's Coca-Cola, Pepsi, Apple, and Biogen. And start and end date. You can add other tickers to find an appropriate ticker. Just go to Yahoo Finance. And here, for example, Yandex. Yandex. And in brackets, it is a ticker. Copy it and yes, you need to install Maxim, use pip install Yahoo Finance. Choose thank you, Dmitry. Just choose companies. You can choose just one and download the data. You can visualize it, but here change the ticker to the new one. Problem. DX. Okay, because it is not serious. Okay, and you can change period and plot the graph. So you can use data from Yahoo Finance or for example, this data set is in pandas. This data set this is not a series, it is a data frame. We need to use pandas. So it has 2 columns, but we need screen. Do you see my screen now? Okay. How to extract this column? Just choose the name of the column, but there is only one, and the name is value. And what we obtain a series. In our previous examples, it was just so the name was y, but now we can write y equals this data set and not data set, the series, and repeat all steps. For example, the first step was splitting the data, and for this data it looks like this. And so it's task for you to repeat everything but using another data set. Okay, just a sec. Okay. Arina, could you send a screenshot in Telegram chat or share a screen if you can? I can stop sharing my screen. If you want to share your screen, or you can send a screenshot. Just remove 9. Okay, Arina. Okay. Could you send a screenshot? Private messengers as a private message or in a group chat.
Do you see my screen?
Yes. Yes. Okay. We need to use additional brackets before Yandex. Y and dx and after.
What do we need here? Repeat, please. What do we need?
Yes. Could you brackets like before, just copy the brackets before y and dx, copy and paste.
No.
No, I can share my screen. And
yeah. Okay. Okay.
What should you do? So you have it works. Strange. Sorry, could you share your screen again?
everything is work now.
Okay. Okay.
Yeah, thank you.
So that's it for today. If you have any questions, you can ask now or write your questions in the Telegram chat. So thank you all. The next deadline. Okay. I'll send this notebook in our Telegram chat. So the next deadline is in 1 week. So you need to complete the first DataCamp course. You can find it in Telegram. This all necessary information about registration, getting access, and so on. If you have questions, do not hesitate to ask. See you next time. Have a nice evening.